Hello, everybody, and we're live today with our live stream. Joining me today, I'm David Jones-Gilardi, Developer Relations Engineer, and I've got Misbah from Langflow and Sandra from Cohere. Hello, Misbah and Sandra.
Hey, David.
Hello,
Hi there.
hello. Oh, I see. Let's see. I see we have some folks from Turkey. If you take a look at the chat, I thought I saw Scotland. Where's everybody from? Like, say hello. Let us know where you're from. We'll give a couple minutes for folks to join in. Also, I see Tommy from Seattle, Bangladesh. Cool. Brazil, Warsaw, the UK. I love how international all of these live streams always are. That's like super fun from that standpoint. While we're waiting for folks to come in, Misbah and Sandra, you guys mind just giving a quick intro? Like, what do you guys do?
Sure, Sandra, I'll go after you.
Oh, we just passed the mic right to Sandra. Go for it.
Let's do this.
That's
Hello,
great.
everyone. Thanks so much for tuning in. I'm Sandra. I am part of the developer relations team at Cohere, and I look after our community Discord server. Highly encourage you to check it out. We chat there on a daily basis about building with Cohere and running into issues, discussing papers, discussing demos and whatnot. I also do hackathons, meetups. I am doing a lot of kind of occasions like this, very lovely opportunities to chat about what's possible with Cohere. So yeah, that's me. Over to you, Misbah.
Awesome. So yeah, my name is Misbah Syed. I'm a DevRel at Langflow. I've been a builder for the last so many years and do the same. So I build, I show examples, and together with Langflow, also hosting hackathons as well as building the community. And happy to join this discussion here.
Awesome. And then, everybody, just a little housekeeping. I see folks are obviously already interacting with the chat. While the live stream is going on, if you have questions, right, if there are things that you want to ask Misbah or Sandra, there is a QA section. So we ask you to go ahead and use the QA section. If you look over to the right-hand side of your interface, you should see a little toolbar there. You'll see this little question mark. And as a matter of fact, I will ask a fake question just so you can see how this works. I'll go ahead and submit it. And then you'll see it pop up, and then you can all vote on them, right? So this is a really nice way for us to be able to kind of like bubble up those questions that maybe are a little bit more important. We will try to get to as many or all of them as possible. And then we can answer them kind of as we're going, and you'll see it pop up there on the screen. I'll ask a fake question, right? So again, try to use the QA for those types of things. Otherwise, have fun with the chat. And with that, maybe just give it another minute. And then what do you think? You want to get going?
Yeah.
Let's do this.
Right, I think we need some, I want to play some like EDM music right now, right? Like, I feel like we need to have some house music. I think in future live streams, Miss, but we're gonna need to hook it up without giving any license constraints. If I drop Dead Mouse or like Alan Walker or something like that, I think we might get in trouble. But alrighty, with that, all right, why don't we go ahead and get started in the content? Take it away, guys.
All right. Do you want me to start, Misbah? All right,
Yeah.
awesome. Okay, folks. So today I have planned to walk through our Cohere models and what they are useful for. I hope to show you some examples of potential implementations and give you ideas for your own projects. So without further ado, let's get going. All right, so the main frame of mind I want you to have about Cohere models is that they are mainly under two categories. One of them is advanced retrieval models, and the other is generative models. You are probably well aware of the generative model bunch, but many folks out there still are not so familiar with advanced retrieval, how it works. So today I hope to show you around that as well. Another good frame of mind to have is that our models are really compatible for RAG and agent type of use cases. So let's start with RAG and then move on to agents later on. First of all, retrieval augmented generation example, super simple. Where do penguins live? My team likes this example. I don't know why, but they seem to enjoy it. So it catches on. Basically, you ask a query, then the model is looking for the information. It's plugged into the sources that allow it to retrieve the most accurate information. It retrieves the most accurate information. It generates a response. It outputs a response, and it cites the sources for this response. So in a nutshell, this is perfect, simple RAG type of use case example. Now, when you want to build a RAG type of system, you need to use these two types of models if you want to be successful as possible. So if you have a query, a question about where do penguins live, you are going to go through multiple stages. First is going to be the retrieval stage, and then there's going to be the generation stage. And so our models fall into these two, and I'm going to walk you through these main model categories. So let's start with the advanced retrieval, because this is the less known part and the secret sauce of many startups and successful companies out there. If you want to build a moat, you're typically tinkering a lot with embeddings, and you save up a lot of money embedding the information out there. So the first step for RAG is dense retrieval, and we do that with embed. Typically what happens is you have some sort of data source. It could be database that's residing locally on your machine. It could be being plugged into dynamic data source like web search, but you want to be able to reach out to it and then search through that information that resides there. And embed models are perfect for that. Embedding models are models that are taking all this data source information, they turn it into numerical representations that allow us to match how semantically relevant is that information that resides in the data source to the query, so to the where do penguins reside. So essentially, you have your data, it goes through an embedding model, and what happens as an end result is the embedding creates the vector representation of that data. Now, here's an example of a vector space. As you can see, you have a bunch of vectors in this space, and they are grouped according to the topic of the sentence. So you have 5 groups here, and they have topics that are not very connected to one another. So they are grouped according to the topic that is most relevant to a particular sentence. In the first case, you have bananas, then you have Einstein, then you have some frameworks, then you have Mark Zuckerberg and Facebook or Meta, and then you have some chemical-based knowledge. So what vector space helps with when you have an embedding is if you embed both the query of a question, so where do penguins reside, or in this case, who created Facebook, then you are going to be able to match with the entire data source and find the most relevant cluster, the most relevant space in this vector space that's very similar to that query, and hopefully find the most relevant information about that query to give it back to you. So in this particular example, who created Facebook, the query is the most closely connected to the bottom lower right cluster with the Facebook and Mark Zuckerberg sentences. So that is how the system is able to connect the two and then output the most relevant, most accurate information. So what's important to note here is that our embeddings are not only good with finding the most similar topic of a given sentence or of a given piece of text, but also the highest quality of that text. What we have put a lot of attention to for our latest embedding model is it's able to look at all the information that you have around a specific topic, and then on top of that, still organize it in a way that will help it figure out which information is the most relevant, which is the highest quality source of information. We've done this test on top of big corpus of research papers on COVID-19. During COVID, there has been many papers published, and they are perfect kind of a research case study for us, because the quality of those papers is has varied widely. So you have papers that are really not super high quality, you have papers that are super high quality, and now when you're trying to look for relevant information about COVID, you want to be able to tap into not only papers that are talking about COVID, but also talking about COVID in a way that's the most informative. So you have two examples head-to-head, where when you have typical embeddings, what they do is they are going to come up with the most with the most similar topics, whereas in case of our embedding, they are also able to come up with the most with the highest quality of information. And here I want to show you a snapshot of what I'm actually working on and use embeddings for. So embeddings are really useful to, when you have a big data source, to kind of cluster information according to this semantic relevance and the quality of information. And I am currently working on a help page for our community, and we keep having a lot of questions that keep being very similar to one another. So I figured that we're going to create a help page with frequently asked questions that community is really interested in. And so what we did was we pulled these questions out of our Discord server, and then we clustered them into clusters with different types of topics. So it could be pricing, or it could be embed model, or it could be generative model. And then on top of that, we were able to organize the information in a way to create a help page. So it's still work in progress, but I want to show you a real life example, very relevant to me right now because I'm working on it right now as we speak. Okay, so embedding is just the first step of this RAG pipeline, RAG process. So we have embedded the information, we have created this vector space, and the query is matching the most relevant information in our corpus of data. Now, the next step, if you want to have a really optimized RAG pipeline, would be re-ranking those search results that you're getting. And this is the second type of model that we have, called re-rank. And it really is designed to optimize the search results. It doesn't have to be optimizing search results on top of the embedding corpus. You don't have to use embed and re-rank together, although they work best in tandem. You can also use re-rank on top of regular keyword search. So let's say you have like some sort of lexical search system already, and you just want to improve the output, the final output, and make the search even more precise than it already is. You can use re-rank successfully for that. So it's really useful for when you have more complex types of data. So again, we have this vector data space. And what happens sometimes, or oftentimes actually, is that in these clusters, you have information that is very closely similar to one another and somewhere in between as well. And you want to be able to tap to kind of like the really fine-grained level of information that the user is looking for. So what re-rank does is, once it gets the documents from you and it gets the search, the search candidates, so to say, let's say there's 100 of different types of search results that match the query somehow, re-rank is going to organize them in a way that is going to tell you, look, this is the first top 3 results that I think are the most relevant to your query, and you can use those to give the answer to your user. Okay, and now I want to show you an example of an advanced retrieval demo. So I need to switch the tab. Bear with me. Oh, there it is. All right, so here we have here have really nicely outlined the differences between different types of searches. First, we have a lexical search. In the second row, we have embeddings. And then in the third, we have Cohere re-rank. So adding on top of embeddings the re-ranker model and seeing where it helps. And so we created a dataset that composes of archive machine learning papers within a specific range. And so we are able to query the system and look at the different types of information that it outputs. So for a query, when was the transformer paper published, the lexical search will output some papers that are relevant, and perhaps Aidan Gomez is second author or whatnot. Embedding search will go to the transformer directly, and then Cohere re-rank is going to pull up the exact paper that you're looking for with the date, so that you can see exactly when this paper was published. So you can see that the more granular you go, you can really tell the difference between similar type of search to search that is more topically relevant to search that is re-ranked on top of the topic relevance, and then the most the most viable candidate is outputted. So that's just an example of how it works. Going back. You can actually give me some questions. I can show you the re-rank itself.
Actually, I cheated. I put in my own QA question. Because we haven't, and for those who are watching right now, again, don't be shy. If you've got questions based off anything Sandra's talking about, go ahead and drop it into the QA. But I do have a question that I'm curious about. I'm curious to know if some of our other listeners are wondering the same thing. So, because I'm actually wondering this. How is re-rank different than what a regular semantic-based vector search will return? Shouldn't the initial vector search order the top K based off of the similarity to begin with? So if I'm getting the most relevant documents based off my vector search, what is re-rank doing differently to give me that more accurate representation of the similarity data?
Well, it's a different architecture of a model. So it's going to just process the information differently. Re-rank is a decoder model. So it's going to decode the information. I don't know exactly specifically like what happens inside, but what I know is that thanks to its architecture, it's able to rank the information according to the most relevance.
So it's different from like a transformer model, which a lot of the stuff that, when we're initially converting our data into vector embeddings and storing that and using it with our vector search, this is just a different approach, essentially.
I mean, so it uses transformer architecture to some extent. Transformer architecture typically has encoder and decoder. Re-ranker focuses on the decoder side of things. So it uses partially the transformer architecture.
Okay, awesome. Thank you. There is a question here from Akash. Oh, go ahead, Sandra. Were you going to say more?
Yes. No. I was just showing you the demo. So.
Okay.
So if you want, you can give me some examples of search results, and then we can look at Wikipedia, for example, and see Wikipedia search, classical Wikipedia search versus re-ranked Wikipedia search, and what kind of difference it makes. Any ideas?
I liked your COVID ones, by the way, because I was going to ask you if those were the actual search results from the OpenAI one you showed, because I love it. It was like, COVID is bad. COVID's really bad. And that was as much detail as it gave,
No, we did. These are specific examples of this data set that we've been looking at, and we've been comparing head to head with other embeddings out there, just to focus on the quality of the information. So yeah, so it gives you an idea of how much more powerful it is to be able to focus on the information quality. And this is, I mean, most of the use cases I can think of. Devavrat has a good point on embedding model encodes the text into fixed length vectors, and re-rank model gives output the relevance score for each query document pair.
Excellent. Okay, very cool.
That's better than me.
Okay, wonderful.
All right. So moving on, let me now talk about the rest of the stuff we're cooking. Okay, so now start of the show, generative models. We know about them, we love them. We have an intuitive understanding of how they work. Our embedding models that we focus on currently are command models, command family. And we've released in Q2 two models, Command R and Command R+. They are optimized for RAG type of use cases. They're optimized for using tools. And they are small enough to be very scale friendly. So if you're thinking about creating a system, putting it into production, making sure that the cost of the entire operation is optimized, Command R and R+, they are in the sweet spot category with 35 billion parameters and 104 billion parameters. So we're not aiming for like the next biggest beast generative model out there with infinite capabilities and moving closer and closer to AGI. We're very much focused on the enterprise types of use cases and pains. And what we hear from our enterprise customers most often is that they're interested in cutting the cost. They are interested in simpler types of retrieval use cases. And what they need is working with a model that is trained on top of those and also is small and nimble enough not to break the bank. So yes, you can access Command R and R+ both via our API, but also we released the open model weights. So this is a thing that I think was met with a lot of enthusiasm from the community, because oftentimes we want to be able to check how the model runs locally for security, privacy reasons. Obviously, you don't necessarily have to connect with our API. So you can go to Hugging Face and download the model and play with it yourself. Having said that, we're still running a business here. So if you're interested in productionizing your use case, you are going to need the production type of license. But for the demos, for playing, for fooling around with the model, I've heard people building productivity agents where they help them focus on a particular window when they are working rather than 100,000 other windows that they have open on their multiple screens. So that's the type of fun use case that you can play with Command R and R+, and they're really good for that. I've heard from people that they are by far the most verbose, most cognitively their models when it comes to the locally hosted models. So definitely, if you're interested in that, you should check it out. Yeah, here are just examples of people really excited about the open weights. Currently, we have almost 500,000 users using open weights of R and R+. So yeah, they really took off. Really excited about that. So now, the second stage of the advanced retrieval augmented generation is the generation part, and Command R and R+ are really good for that. And we specifically trained the models to be good for that. So we trained the models with access to tools, access to different APIs, access to different types of information sources in mind. And they are very much aligned with those types of use cases. So first up, what we're trying to do here is we have the model, it decides when the external information is needed to give the output to the user. Sometimes it isn't, and it's important to have to make the right call and not end up going to call a number of tools, but rather, focus on the answer that it has already baked in its pre-trained knowledge. The next step would be operating the retrieval system smoothly to run the search queries. And in here, it's going to work together in tandem with the embed and the re-ranker. Then it uses this retrieved information as a grounded context for the conversation it's having with the user. And then it outputs the generation that is the final response enriched by this relevant information that it retrieved from somewhere else, and it's going to add citations on top. So we are really big on citations. They are built in, and we really believe that when you have a model that is making claims, it's really important that you can verify whether the source of information is relevant for you, whether the quality of this source is what you need, and also track back where the model got this answer exactly. So we're really about transparency and making sure that you are able to track that. When you work, when you use command R in tandem with embed and re-rank, we are running RAG benchmarks internally on famous datasets like KILT for RAG capabilities. We see that when they work together in tandem, they are really outperforming any type of generative model per se that's available out there. So it's really good to use them together.
You know, Sandra, I saw a really great question that just popped up in the Q&A that is really relevant to what you were just talking about. Kailash asks, how do you ensure that a citation is actually a trustworthy source?
Well, that's a great question. I guess you can, the way you're ensuring it when you're working with our API is that you specify the information sources that the model has access to. So you can decide, you can really give it the specified, let's say you can ground it on specific domain of the website instead of just giving it access to the internet, or you can just give it access to this closed data set of a number of documents, and so that it's going to look for the information grounded only on top of this type of data. So you have control over that.
Awesome, thank you.
All right. So we started with optimizing models for RAG, and it kind of organically sprang into optimizing the models for tool use. We really, as I mentioned, we have this RAG formula where we trained the models and optimized them to work with information retrieval. But now the very same formula can be used when it comes to using tools. So by tools, I mean different types of APIs, search engines, SQL databases, vector databases, Python interpreter, all kinds of calculator, all kinds of tools that you might want to use. And it works very similarly. So the user query comes, model decides whether a certain tool should be used. It's going to use the tool, or it's going to output the answer if the tool is not needed, and then use the answer coming from this tool to ground the answer that it's going to output into the user, and then it's going to cite sources as well on top of everything. Now, when it comes to tools, there are two flavors. There is single step, and it's really useful when you have use case when the model only needs to perform a single action or set of independent actions that can happen at the same time. So for example, if you only want to be able to do a document search, or if you only want to be able to send out an email, that would be a perfect use case for single step tool use. But you can also use tools in a sequence of steps, and we call it multi-step. So it's designed for situations where model needs to carry out a sequence of actions. Each action is going to build on the results of the previous ones, and then in this case, you might want to be able to search for the document, compare it with another document, and send out a summary email to your colleague with, talking about how these two documents work together. You also want to be able to have the model create kind of a loop where it's going to retrieve the information from these sources many times over until it reaches the right answer. And it's going to reflect and correct its errors that will inevitably happen because some API connection is broken or this or that. Errors happen all the time. So we are really training the models as well now to work with these kind of loops and sequential reasoning capabilities so that they're able to fix whatever's broken. And you know this behavior under the umbrella agents. It's a very fuzzy term these days, but it's a very popular one. What we mean when we say agents or multi-step is basically a software that is performing sequences of steps and using tools while doing that, and each step in that sequence is building on the previous ones. So for us, this is agents. You can use these terms interchangeably. We have released our API where we kind of call it multi-step, but also agent API in brackets. And in this API, we're trying to make it as user-friendly as possible. So you just describe the tools that the model has in their hands, and also specify the data sources if you're doing RAG. And then describe what each tool does and its parameters. Now it's super streamlined with our API request builder in the UI. I'm going to show you if I have some time later. And then once the user request is made, model is going to create a plan, decide how to use these particular tools to fulfill the request. And after each tool has been called, the model is going to reflect on top of the contents of whatever happened previously and adapt the initial plan. So as I mentioned, if it's going to call an API, and API is returning an error, the model is going to think about retrying, for example, and trying to call it again. So one thing that I mentioned at the beginning is that we are not trying to build the most kind of cognitively beefed up models with very complex capabilities with some sort of science of God knows what level AGI. We're really interested in models that can work at scale, and so we find that R+ has the sweet spot where it's competitive when it comes to RAG and tool use with the main generative models like Claude, Opus, or Sonnet, or GPT-4. But at the same time, it's very cost friendly. So this is really what we're working towards, and this is why the models are smaller. Here's just a bunch of RAG benchmarks where R+ is doing really well for RAG and tool use. And lastly, what I want to show you is that so building RAG is kind of partially also a UX challenge. We know it firsthand. We know how painful it is to build a retrieval augmented generation application, having all these kind of elements where you have a nice chat flow with the user, you have multi-turn conversations, they are grounded in multiple information sources, model retains the memory of the conversation, super complex, actually. But we spent a lot of time perfecting our interface. And so we decided that it's going to unblock a lot of builders out there to be able to use the same interface. So currently you can download this repository. It's called Toolkit, and it has multi-step support. It has citations. It has really nice UI that's built really with Next.js and an SQL database for out-of-the-box conversation history. Then you can customize the access to different models. So you can use command R+ either via our platform, or you can use it with our cloud providers, because we're available on, I think, all of the cloud providers with R+. Or you can download the open weights and use it via Hugging Face or private deployments. So go and check it out. It's a great use case.
Yeah, and I just put it in the chat. Down at the bottom, you guys should all see a button that says Cohere Toolkit repo, and if you click on that, it will bring you right to what Sandra is talking about. I believe I've got the right one, Sandra. That is the Toolkit repo you're talking about.
I think so. Where did you share it?
It should be at the bottom of the interface. There you go. Yeah.
Oh yes, exactly. Yeah, that's it. All right. And at the end, I just want to encourage you to go and check out our interface to play with the models. There you go. Okay, so this is the chat interface. Without any code, you can already decide which kind of tools are going to be used for your use case. You can also upload different files here, and you have advanced settings where you can set a different type of model, adjust temperature, change the preamble, and so forth.
That's cool.
But coming back to tools, you can see even in this UI how the model is going to reason on top of, let's say, a little bit more complex queries. So my query is, what are the 3 largest companies in the world in terms of the market cap? How many employees do they have? Create a graph, and then draft a tweet on top of the analysis that you performed. So you can see that it will require drafting some sort of plan and breaking it down into different steps. First, it's going to search for the top companies. Now it tells you that it found the 3 largest companies. Then looking for the number of employees in each company. Then it found the answer. So now it can go into plotting the answer. And I think it broke, or it's still thinking.
Always, the live. I don't know if we gave any sacrifices to the live demo gods when we started today. So
these 3 dots are.
We need to have one of those ready for next time.
Unnerving. Well, we can always retry and see what happens. In ideal scenario, where the demo gods were friendly towards that example, there will be a graph and there will be an analysis with citations, and then you will also have a tweet ready at the end to show it. I think it's just taking its time, honestly. Okay, there you go. We recently enabled HTML rendering. So this should turn into, I think it's my internet actually, sorry for the crappy Wi-Fi, but it should turn into a graph soon. There we go. And each of the information sources is cited where the information was taken from somewhere. So you can, go over, I don't think, okay, you see it here. So you can go and verify where it came from. And at the very end, it's going to create a tweet about it. So this is an example of what we can do today. I also want you to check out the playground where you can actually see what's happening under the hood when it comes to the code. So this is the very same query, and here we have the request and the response, and we're going to see exactly what happened. You can also copy it if you want to speed your development process. We also, okay, there it is. So I have a long response showing what has happened during the call. Oh, there you go. These initial model thoughts, and then lots of conditions. You can also check out the API request builder, and here you can really, this is a UI that resembles the structure of our API request, so it's really easy to build an example request and iterate on top of it. So you can specify tools, describe them, add some parameters, and then see how the model performs with them. And if something doesn't work the way you want, you can always edit, and you can keep the same chat history, so you don't have to redo the same example over and over again to perfect your request. Instead, you can work on the existing example. Yeah.
I'm a big fan of API tools like this, by the way, because I swear half of the development is trying to figure out the implementation API and figure out how to work with it, and then actually get coding against that API. And so having something like that is super useful. So definitely throwing some, I appreciate that, over to the team.
Well, thank you. Yeah, no, we're definitely builders ourselves, and we've been annoyed about this and building demos and trying to put things together. So we're just thinking about how to streamline iteration for like making it more rapid. So hopefully that's going to be helpful. Check it out. Thanks so much for tuning in. Let me know if you have more questions.
Yeah, and to that, Misbah, there are some questions here. How do you want to do things? Do you want to go ahead and get into what you want to show with Langflow, or do you want to try to answer some of the questions based off of what Sandra just presented?
Yeah, maybe actually it's going to be super quick, David, from my side. So maybe we can take questions right after that. I'll try to wrap it in about 5 to 8 minutes or so.
Sounds great. All right, with that, Misbah, what you got, man?
All right, let's
Thank you, Sandra.
go. So, yeah, thanks a lot, Sandra. That was really, really informative. So, at Langflow, a lot of what we do is building an integration and helping out people to drag and drop and then call these models easily. And that's something, we've also done for Cohere integration, be it the LLMs, be it the embedding models. So I just wanted to showcase how that could be done. So gonna real quick show my screen. So right now, I want to start with something very basic, and this is an example we demo a lot, which is where you take a one of these models, LLM. So in this case, I'm using a block from Cohere, and it's going to call the generation model. And before that, I'm adding a chat input and a prompt. So that we can ask. It's quite simple. If you start any of the instance of Langflow, you'll notice that you'll have that option to go with the basic prompting. So that's what I did. And then within that, I said that, okay, this is the usual example that's available in there by default to answer as a pirate. So what's going to happen is when we run this, and within this block, there are a few different settings that one could change. So there's the temperature setting that we see on the main UI here, but there's also more things that you can change. You can come in, add stream. You can actually change the system message if needed. You can look through the code and see what model is it calling, right? And one could also, if you're familiar with code, then one could change which model it's calling if needed.
Hey, now, can you zoom in a little bit to the what you're showing in Langflow? Thank you.
Sure. So let me try zooming in. All right, there we go. Okay, so with that, now if you have a chat input based prompt, and then you want to call that, and I'm just saying, okay, hi in this case, and I'll just give it a try. So what's going to happen, it's going to call the Cohere model, and it will give us some results. We can inspect the results, what's coming out, so I can see that I got a response back in the pirate language, right? So this is a base example. We're calling Cohere model, and then we get some response. Of course, you can go on the playground and also chat over there, or you can inspect further in the logs and traces. Now, starting with this basic example, I wanted to kind of build from there, right? So what else could be done? A couple of examples that I thought might be beneficial. One is the website QA. So if you have a website and you want to scrape and get the content out of that and want to answer, right? You might have a question like, okay, can you summarize this? Or can you look for a particular thing? So what I did, I used this Firecrawl scrape API block. This is something available in one of the later versions of Langflow. It's really nice because you can make an account on Firecrawl, get an API, get started right away. What I did is I took one of the latest blog posts from Cohere, and then I just asked, give me more info about the new features, whatever is listed, right? Or I could have said, what is this blog about? And then what's going to happen is it's going to go through the whole thing. It's going to parse data from the web page and send it as part of the prompt. And I've got this set up over here. Happy to share these templates if anyone is interested. But again, the same thing is happening where we're calling the Cohere model with the context and then trying to answer that question. And once we do that, it's going to go through the same thing. It's going to first try to scrape the website, get some data from the web page so I can look here what's happening. So this is all the text that I got from that blog. And based on that, then we get an answer at the end that basically is that this blog post is about these certain announcements, right? So you can easily scrape websites or ask questions about that. Now, just kind of building on top of that, what if you wanted to add a vector store in here, right? So that's where we can go to the RAG example that was mentioned. So in here, I'm going to start with um, a simple RAG flow, and this is also part of one of the templates available in Langflow. So if you were to start with base template, you'll see that you have an option to upload a file. In this case, gave a test file, or just a PDF, one research paper that I had on my computer, and use that to first initially split the text and kind of, building on where Sandra showed how the embeddings and RAG works. So using that, we split the text, we use Cohere embeddings in this case, and there is an option. If you use Cohere embedding, there are multiple embedding models available from Cohere that you could select. And based on that, you can have the embedding stored. And I wanted to just store it locally, so I used a Chroma DB and gave it some name to the collection and also a directory where I want to save these embeddings. And then once I do that, then first thing I'll see it in the folder wherever you're running Langflow, that this Chroma folder is now with some embeddings in there, right? So it works. So I mean, I know in that case that this worked fine. It did the embedding portion. Now the second part, if I want to retrieve those embeddings, then what I can do is I can use those embeddings together with the vector database and then parse the text, the data out of that, include that as part of the context. So we're saying based on the above context from vector DB, answer as best as you can, and then from there we're using a Cohere model here and get some results based on that. So again, this is a base embedding model. I could have used multilingual and probably upload document in one of the languages supported by Cohere. And in addition to that, let's say, for example, you want to use a re-ranker in here, then there is a re-ranker block as well. So what I'm going to do is, perhaps it was this one here. Let me make sure. Okay, so this one here. So if you were to just search the available blocks in here, you'll find the Cohere model, the embeddings, and the re-ranker block available. So I can just add an additional block here as re-ranker to the vector embeddings that we're getting, retrieve the results from the vector, the Chroma DB, and then from there I can re-rank. So I'm saying I want the top 3 results, right? So just to check, right? So let's say, for example, I said, summarize this document for me, please. I can run up to this stage. I get some values in here. And these are all the results that I got. Then one of the cool things recently that came out, I can freeze the results, and then I can run the re-ranker and see what is it going to do, right? The top 3 results that I get out of that. And these are the top 3 results that I get with the relevant score. So now I know these are the top ones that was captured. We can go up on these values or lower on these values as needed. Same thing on the vector results that we got. And then based on those 3 top results, now we get our response. So again, these are all the different integrations available. In addition to that, Command R could also be used. So that's available on Ollama. So in Langflow, you can use or call any of the Ollama models. We also have some videos on that, so feel free to check that out. But once you use that, then you can call the Command R model in there as well. So yeah, hopefully that gives an idea of the different integrations. Those are available in Langflow for Cohere models, for embeddings, for re-rankers. And of course, if there are more things that you would like for us to add, reach out to us. We'll certainly add those tools in there. So yeah, David, with that, back to you.
Awesome. Funny enough, I did not realize that you guys had support for the Cohere re-rank. That's super cool. Because it makes it like, it's just way easy to iterate on and go experiment and test and everything. So yay. So definitely, something about going to the latest version of the, what is the latest 1.0 version that we're on now, Misbah?
I believe it's 10. So
okay.
1.0.
So that's 10 that you're showing today?
That's probably one behind. So it's
okay,
going to be, I believe it's going to be merged today.
Okay.
10.
Okay. Super cool. Awesome. All right. So we have a set of questions in the QA. One of them is super easy that you already answered, but I figured it would be good for everyone to know. Will this presentation be available later? Yes, it will be on the Langflow YouTube channel. So go take a look at that. And then, I don't know how long it takes, Misbah, once Crowdcast finishes for it to get published. You have an idea there?
Yeah, perhaps later this afternoon. So about maybe 3-4 hours from now, we should have it posted.
Okay, but the answer is yes. Now, so the meatier question. We have some good meaty ones in here. You guys ready for some meaty questions? So Sandra, I think this one is for you. And this goes back to some of the stuff you were talking about before. Is there a list of text/dataset sources which are used to train these embedding models?
Let's think
And that's
about
Prakash.
that. I'm not sure whether we have like a publicly available list. I know that we're for sure it's called like data indemnification. So if we have trained our models on top of the corpus of data, and then there's going to be like a legal dispute because of the source of where that data comes from, which is a common thing that happens these days. We protect our customers from the process, and we I don't think we've ever had any issues with using data sources that are not really for us. But what do we train the data on? Well, I can tell you that we train on different modalities these days as well. So I cannot tell you exactly what we train on because I have no idea, but I can imagine it's going to be a healthy chunk of research papers involved in there. But the interesting thing that I know of that is coming up with our models like Compass, which is in beta, is that they are also being trained on visual as well as textual data. So they're going to have some really interesting capabilities moving forward. So sorry, I cannot answer very specifically, but yeah, stay tuned because we're covering more and more use cases.
Go ask Cohere, what have you been trained on? I've tried that with actually a couple of, even OpenAI is like, no, man, no, I'm not, I don't know. Alrighty, cool. Thank you. And let's see, we have another one here. What opportunities exist? I'll put it up. What opportunities exist to work with Cohere and Langflow dev advocate teams to host hackathons? Misbah, this might be, well, actually, no, this is for both of you. I'm organizing one in October and am interested in helping non-coders and coders work together with multilingual tools. And that's from Don Hayes.
Sandra?
Yeah, so we constantly organize hackathons, actually. Please reach out afterwards. You can find me on Twitter or LinkedIn. I'm going to type in my email as well, so you can reach me. And then we're going to talk about it because we get a lot of questions about that, as you can imagine. So we are really prioritizing when it comes to the type of features that are coming up in our team capacity, because it's also fairly limited. So please reach out and then we can talk.
Yeah, likewise from Cohere, from Langflow side as well, right? So we did one recently with LabLab Global Hackathon. We are organizing a few competitions in different parts of the world, but always open. If you have any ideas or if you're organizing, reach out to us and we'll be more than happy to collab.
Alrighty, excellent. Now I got another chunky one, probably for you here, Sandra. There are several methods for dimension reduction to visualize vector databases, such as UMAP, PCA, and TSNE. Which methods are being used currently to visualize and cluster the vectors?
Well, I've seen projects using UMAP, and I've seen projects using TSNE. I don't think I've seen PCA, but regardless, I encourage you to explore. This is not, there is no kind of like set best practices. If you have a tool that you think could be useful in visualizing your use case, then I encourage you to check it out. We do have a bunch of examples with UMAP and TSNE, so I can link them below if you're interested.
Yeah, if you've got those, yeah, I think that's a great idea.
Okay.
Here, while Sandra's doing that, I think, Misbah, I may just take this next one because I love this question, actually. Langflow deploy. This is from Akash. Langflow deployment. Is it possible to convert this flow to Python code? So yeah, as a matter of fact, Misbah, if you want to share your screen, while we chat about this. Like, there's actually a couple different ways you could do this, Akash. One is within each of the components themselves, there's a little, if you hover over it, there's a little dialog that pops up, a little code block component. I think Misbah is just about to show it. And there's Python underneath the hood. Every one of these is wholly contained a Python module, right? So you can get at it this way. Now, I think part of your question is asking, can I take the whole flow? And can I just export it as a big old, set of Python or something like that? Not currently. However, that I feel that actually slightly defeats the purpose of what Misbah, I think, is just about to show you, which is if you go to the API there, you see in the lower right-hand corner, there is an option to export the whole flow as a JSON blob. And when you do that, it takes you no code. I mean, you could use the Python API or JavaScript API directly, but this one right here, you can just export the whole thing as this JSON blob. And it actually encapsulates all the logic and everything in that blob. And then you just need this one package to load it. And essentially, you're then embedding your application with all of the logic and everything from your flow, right? So you don't technically need access to the Python if you didn't want. If your follow-up is then, well, I want to make, I want to modify that Python code. Well, then you can actually do that there in Langflow. So you can modify any of the Python. You can create custom components, and then you can export it as that JSON blob and still reflect those, right? So I think it depends on what you're looking for, but you always have access to underlying Python. Misbah, is there anything you want to add to that?
Yeah, perhaps just, the API side of things as well. If your goal is just to run some backend workflow and have your UI just communicating with that, then you can explore these options as well, running as an API and then calling your Langflow instance, right? So there is this base URL and the flow ID. Based on that, you also can tweak certain parameters and then call using that. So many folks, they want to take this, run it on a separate server using Python. You don't necessarily have to if that's the only use case. If you just want to call it as a backend API, I usually recommend just have this deployed instance somewhere where you can access it and then just call this API. Yeah, I would probably just add that, and perhaps just to add to the export option, so you can go to your settings of this project, and then in here you see an option to export. So this will give you a JSON of the full flow that then you can run using the Python code that we saw in the API blog if needed.
Yeah. One other thing I want to say quickly about the API that you were just showing, Misbah, is at least personally for my own development, what I really like using, separate from the JSON blob, the API for, is when I am iterating in development, like stage and that kind of deal, and I am working through, like maybe I am exploring different models, I'm exploring different prompts and parameters and things like that. I'm working through it, but I've hooked up my app, right? Because I'm kind of doing like a call and response, right? I've got my app wrapped around the Langflow piece. I want to see what's going on in both, but I'm not ready to version the thing yet and say, yes, this is my absolute flow. I love using the API server like that because I can just go and modify things on the fly at runtime. And then when I'm good and done, I can, export the flow or something like that. But yeah, Akash, if you have any more you want to know about that, please drop it in the message there. All right, Sandra, I think I have another good chunky one for you. You get all the chunky ones today, right? All right, so let me go ahead. This is Kailash again. In cases of context documents, such as the website example shown, have you seen cases where the document could be something with a bunch of numbers, charts, such as a data report, and we can feed that document as context and summarize it for the user? The use case being reports are generally hard to interpret without a bunch of explanation for most folks.
Yes, you can imagine, because we are working with enterprises. They're by far one of the most common ways to communicate findings from one team to another with an enterprise is creating a report, having a bunch of charts, having a bunch of numbered lists and whatnot. And you can use I've shown you the UI where you can upload files. I've been playing with like Walmart's K10 filings and whatnot with reports with images and text, and the text is semi-structured or structured or unstructured, and is doing really well on those. So yes, it's possible today. Go check it out.
Misbah, I'm realizing now between Cohere and Langflow, we should have a template that is creating TPS reports for anybody who happens to know that reference to Office Space. If not, I'm sorry for the bad joke. But So by the way, a question just popped up here from Raymond. Any inside info when the share functionality will work within Langflow? That's actually, I'm super curious about that, Raymond, because it does work now, and I'm curious what isn't potentially working for you. Yeah, and if you're talking about the share to like share it up into the community store, or what aspect you're referring to there. Let's see what if Raymond. Raymond with 100% TPS reports. I'm great. At least one person got that joke. Yeah, Raymond. Yeah, if you can, try to type up something there in the chat with regard to what you're seeing. Because Misbah, again, wouldn't you mind showing, like, go into the share? You can just put it right there in the message, and yeah, put it in the chat, Raymond. That's fine. Having like a live conversation with Raymond over message. But yeah, I like if he goes to share. And I almost wonder it might be an API key thing. Like you need an API key to the store for that to.
Yeah, I think
It
I
looks
don't
like you
have
don't
it
have your
enabled.
API key.
That's right. Yeah, I don't have my API key right now added to it.
So
But yeah,
Raymond, is that what you're seeing? Are you seeing the little crosshatch when he hovers over share? Because if that's the case, you need to go to the Langflow store. I think I'm totally putting Misbah on the spot right now. You need to go to the Langflow store, share the playground, like a hosted app.
And add the API over here.
Okay. I think Raymond's asking about sharing the playground, but in this particular case, you just need an API key from the Langflow store, and then once you add that into Langflow, that will all resolve. But if I'm correct, I think Raymond, you're saying share the playground like a hosted app. So you mean like being an embedded, like in HTML or something like that, where you can actually like treat it like a chatbot or something?
So maybe,
okay, got you. Yeah, okay. Go ahead.
Go ahead. Now, I was just going to mention maybe while that info is provided. Yeah, so I mean, one thing is we usually share these flows to the store, right? So everyone can access. That's one. For the hosted apps, if it is just like something deployed to platforms like Render, Railway, or your own server, then I'm assuming that's the question, David. You can correct me if I'm wrong. So usually, then you can get these API, and then you can call these APIs, right? So if that's the question,
I think what he's asking is for the chat widget HTML. I think from what Raymond was saying in the messages, he's looking for a way to essentially embed the playground, like the chatbot portion.
I see. Yeah. So that will be with this chat widget.
Nope, HTML. Not quite.
Okay.
I don't know if you're watching Raymond's messages here. This is real-time conversation over. Raymond, what we might want to do then is go ahead and actually we could invite Raymond to talk. We haven't done that yet before. Do you want to give it a shot?
Yeah, I would suggest, Raymond, if you don't mind, we're going to do office hours, so we do it usually on Fridays. Hop in one of those, and I think that'll be easier. We can also run through a debug session or so if there are issues. Yeah, I think there might be some permission issues if we start the audio channel.
Okay. All right. Yeah, no, that's a great idea. Actually, I forgot about the office hours, Misbah, so I appreciate you offering that up. Do we have a link or anything that we can give folks for the office hours, somewhere that Raymond can go to?
I would suggest if you're on Discord, we'll announce that, so you'll have a link available. Sorry, I don't have it on me right now. Let's see. But yeah, I would suggest if you're on Discord for Langflow, then you'll see an announcement soon.
Okay, and you know what I'll do is I will put, I believe the Discord is right there. Yeah, if you go to langflow.org, I'm just going to pop this. You're in the Discord. Perfect. Okay. For those who aren't and are interested in this, if you go to langflow.org, you should see the link there in the message. You'll see the Discord is up in the top right. Just click that and you can join. All right. And let's see. I know we're pretty much at time. The last question, I think, Sandra, this will be super easy. Sandra, is there a trial version for new devs to try Cohere models?
Yes, so I responded to that one already. Yes, there is. We have a very generous premium tier that allows you to use all our models, all the versions, and the only caveat is that it's rate limited, so you can check out the rate limits. Once you hit the rate limits, it probably means that you're ready for production. So then you can update to another key. But yeah, you can go and check it out right now with no bugs involved.
Alrighty, excellent. Thank you. That's all of our questions, and we are definitely at time. Thank you for all the interaction and folks in the messages and your questions. Thank you to Misbah and Sandra. I learned a ton, by the way, about the Cohere stuff. I've actually been very interested, so this is like super timely. And with that, everyone, take care. Have a good rest of your day.
Thank you.
Take care, folks. Thanks for having us.